𝗬LT is a tool that lets you move data from different sources to different destinations in Python. And this is very common in startups and in big businesses. You might have data sources spread across different platforms, and you might have some kind of analytical tools and analytical steps you want to perform that requires the movement and transformation of that data from these sources to various destinations. So we're going to look at 𝗬LT in this video with a practical example. And we also did a video recently on dbt, which is a similar tool for the transformation stage of an ELT pipeline. And I'm going to add this video to the same data engineering playlist. Check that out below the video. So let's get started, but before we do, if you want to support the channel, check out the Ko-fi page we have below the video. And if you want to join the channel, there's a link below the video as well. And don't forget to give the video a thumbs up. Now, 𝗬LT in a nutshell is a lightweight Python package that allows you to move data around. And it comes with a lot of nice integrations. And you can see it's been used by many big organizations. PostHog is a tool that I really like, and that's one organization that's using 𝗬LT. And it's very simple to install. You can just run pip install 𝗬LT, and you can also use UV if you want. So to get started, I'm just going to copy the pip install command, and let's go to VS Code. I have a Python virtual environment activated in an empty directory otherwise, and we're going to paste that pip install command. Now, 𝗬LT, as it says here, is the most popular production-ready Python library for moving data. And it can load this data from various and often messy sources into well-structured live datasets. Now, if we look at the examples here, you can see some of the sources. For example, cloud storage is a source. This one is an S3 bucket, and this is using the file system resource, and it takes the data from the bucket, and then it creates a pipeline to move that data to a DuckDB database. And of course, you could use any kind of database here. And then at the bottom, we run the pipeline. That's an example with cloud storage. You can also use REST APIs. We'll see an example of that in this video. And you can use normal relational SQL databases and also any kind of Python data structure. Now, we'll see more about the integrations later on. But I want to go to this page, and this is going to highlight the benefits of 𝗬LT. So as this diagram displays, often you have a lot of sources in your application or your business. And this can be databases, APIs, but it includes tools like Jira, Zendesk, Stripe, Salesforce, Google Analytics, Slack, and so on. Lots of different sources, Notion as well down here, and Google Sheets. So 𝗬LT can take data from all of those sources, and a lot of these sources can be unstructured or semi-structured data. And 𝗬LT allows you to extract that data, normalize it, and then load it into different data sources at the destination. And these destinations can be more optimized for analytics and retrieval. For example, DuckDB, of course, but we also have vector databases like 𝗬𝗍𝗓 and also Quadrant. And on top of that, we have data warehouses like Redshift, Snowflake, and Databricks, cloud storage like S3, and databases like Postgres and SQL Server. So lots of different destinations you can load the data into after it's been extracted and normalized from these various sources. Now, if we look at the concrete example here, we import the 𝗬LT package and we run the 𝗬LT.pipeline function to create the pipeline. Now, this is the main building block of 𝗬LT, the pipeline. It orchestrates the loading of data from a source into a destination, and it runs 3 discrete steps when you call its run method, as we're doing here. So notice in the pipeline, we specify the destination, which in this case is DuckDB. And then we take this source data, which is a simple Python list, and it's going to load that into the table called items. So we have some source data and we have a destination, which is DuckDB, and the pipeline.run method is going to handle the extract, normalize, and load process. Now, I'll leave a link to this if you want to read more into these different phases. And if you do want to know more about DuckDB, I've added those videos to the data engineering playlist as well, which you can find a link to just below. Now, I want to go to the notable 𝗬LT features. First of all, 𝗬LT is a Python package, so it's going to run anywhere that Python runs. And that means you can run 𝗬LT locally, you can run it in notebooks or on orchestrators. And I think this is an important one. 𝗬LT allows you to build and test your data pipelines locally with DuckDB. And then you can switch out the destination for deployment, for example, to Snowflake or Databricks. And there's also streamlit integrations that provides a nice user-friendly interface for accessing your data in Python. We'll see a bit about that very soon. Now, before we do a practical example, I want to load one more page here on the pipelines in 𝗬LT. And as mentioned before, pipelines move your data from Python code to a destination. And we can create these pipelines by calling the 𝗬LT.pipeline function. And each pipeline can have a name, a destination, which is where the data is going to be loaded into. And you can also provide a dataset name, and that can be a logical group of tables, for example, a schema in a relational database, or a folder that groups many files. Now, I think it's best at this stage to get started and actually create a pipeline in 𝗬LT. If you want to know more in detail about these core concepts of sources, resources, and pipelines, and destinations, and so on, you can check out the documentation here. But notice under sources, we have a lot of different sources here for different platforms. Even things like Asana and chess.com are potential sources, as well as 30 plus SQL databases. So lots of options here. We're going to use the REST API integration. So we have a source here for REST APIs to extract data from a REST API and then load it into a source. Now if we go to the getting started, we can see a page on loading data from a REST API. And this is going to use DLT's REST API source. And this example uses Pokemon. We're not going to do that. I'm going to build something a little bit more simple just to demonstrate the basics of this. But what we can see on this page is the ability to set up a new project using the DLT CLI tool. So you can initialize a DLT project with the DLT init command, and then you can provide a source and a destination. In this case, the source is the REST API source, and the destination is DuckDB. Now we're going to follow this example loosely, so let's copy this command and let's go back to the terminal. We now have DLT installed, and you can run DLT-- version to verify that. And then we can run the DLT init command, and that's going to initialize this project. And you can select yes to this, and it creates the project on the left-hand side. So what's actually been created here? Let's minimize this terminal here and go to the files on the left-hand side. So we have a REST API pipeline.py file, and here we define a DLT source, and it's called GitHub. And then underneath that, we have REST API config for GitHub. And we also have authentication details here. Now we don't need any of this because we're going to build a more simple example. So what I'm going to do is basically just remove all of this code here. We just need the folder structure that we have on the left-hand side. So let's remove all of this, and let's just bring back the imports we need for now. So we're importing DLT, and we're also from dlt.sources.rest API importing the REST API source. And this is the source that allows you to create and configure a REST API source for data extraction from that API. That's what we're going to do in this video. And then we have this block at the bottom for actually running the script. Now, how do we instantiate this REST API source? Let's go back to the documentation. We're going to use this declarative configuration to define the API endpoints and their relationships, and also how to handle pagination and authentication. Now, we're going to keep it a bit more simple than this. What we're going to do when we instantiate the REST API source here is we're going to provide a client key to the dictionary, and then we provide the base URL to that. And then underneath the base URL, you can provide sources, and these are going to be different endpoints that you can add to the base URL. For example, here we have api.example.com as the base URL, and the resource of /posts will be used to fetch data from that particular endpoint. So in the client section, we're going to define a base URL. And if you do want to provide pagination and authentication options to the API, you can do so in this block. Now, to keep things simple, I'm going to use JSON placeholder. And if we scroll down, this gives you some endpoints that you can use for an application just for testing. And it's going to give you back some data. For example, /posts, we're going to use that. And we're also going to use /users. So what we can do here is we can copy the base URL and go back to VS Code. And let's start defining our REST API source. We'll create a variable called source, and let's instantiate the REST API source and provide that dictionary of configuration. So we need a client key here, which is going to be another dictionary. And that client is going to have a base URL that we're going to use. And let's set that to the JSON placeholder URL. Now, once we have the base URL, we can then define the resources underneath that base URL that we want to provide by creating this resources block. And I've created a dictionary here, but this is actually going to be a list of all of the resources you want to include. And the simplest way to do this is just to pass the routes that we want to fetch. So for example, users and posts. And as I said before, that basically takes the base URL and adds each of these as resources and fetches the data from that. Now that's a simple configuration. We don't have any authentication or anything like that, but it's very easy to add these with DLT. Once we have the source, what we can do is create a pipeline object. So we're going to use dlt.pipeline here to define this pipeline. And I'm going to explicitly give these keyword arguments just so we see what each part of this pipeline is. So let's start with the pipeline name. I'm just going to call this JSON placeholder API. And we'll set a destination here, and I'm going to set that to DuckDB. And then we can save that. And if we go to this block at the bottom, what we can do here is we can call pipeline.run. And we're going to pass the source in here. And the source, remember, is what we defined up here. It's the REST API source with this configuration. So let's go to the terminal and let's just clear what we have here and try and run this. So it's Python REST API pipeline.py. We're going to run the script here. And we have this exception here, and it's the missing dependency exception. And of course, we've set DLT to be DuckDB to be our destination here. But we haven't actually installed DuckDB, so we need to do that just now. Let's just copy this command and we can paste that in to install DLT with the DuckDB extensions. And you can see at the bottom that has now installed 𝗏db. We can clear the terminal and let's try running this one more time. So we're running Python REST API pipeline.py, and you can see on the left hand side what's being created here is a 𝗏db database file. So by running this pipeline, it's created a database, but what is actually in that database? Well, we can actually inspect that using DLT. So what I'm going to do is load up the documentation. And here we have a page on viewing the data with Streamlit. Streamlit is a nice UI application builder for Python. And what we can do here basically is that once we have run a pipeline locally, we can launch a web application that displays the loaded data. And of course, for that to work, we do need to install Streamlit. So let's copy this command and we can go back to the terminal and install Streamlit. And let's go back to this documentation here. To launch the Streamlit application, we run the show CLI command. So DLT pipeline is the subcommand we're going to run here. Then we specify the name of the pipeline and then the show command. And this pipeline name is what we defined in the Python code with the pipeline name argument. So let's go back to VS Code. This is the argument here. It was called JSON placeholder API, so I'm going to copy that. And as soon as this installation, which is for some reason taking a long time, is finished, we're going to try this out. Okay, so that is finally finished. Let's clear the terminal and we can run that DLT pipeline command. We'll paste in the name of the pipeline and it's the show command. Let's see what happens when we run this. This should start the Streamlit application and you can see it's found the JSON placeholder API and it started the Streamlit app in the browser, and we can visit that locally using this URL here. So let's do that just now. So here we have the application and we can see the two tables that have been created in 𝗏db here. The first one is for posts and the second one is for users. And we can also see the names of different columns in the table and their data types and also whether they are nullable. Now we can also show the actual data in the tables. So if I click this button here, here is the data that's been loaded from the JSON placeholder API. And notice we have a user ID here. So each post is tied to a user, but this is not going to explicitly create that foreign key in the database. And we'll talk more about that in a second. And then if we go to the users table and show the data in that, you can see the data coming back from that dummy JSON placeholder API. It's all now being loaded into this destination, which is a 𝗏db database. And we have two tables in that database for the posts and the users. So that's a very simple configuration here for getting data from a REST API and from different resources under the base URL, and then creating a pipeline to load that data from the API into a destination. In this case, we use 𝗏db. And as I said earlier, you can do this testing on 𝗏db locally, but later on you can switch this out after performing transformations or whatever you're going to do, and maybe use something like Snowflake or Postgres, or even a vector database like Quadrant. Now I do want to mention something. You might be thinking, what on earth is this guy doing? This is just a REST API, it's a dummy API. We don't need this extra package to load this data into 𝗏db. But the idea here is that we're just showing the basics of the REST API source. But DLT is going to be very useful when you have data across multiple different sources of different types, for example, cloud storage, APIs, databases, and so on. And also external systems, as we saw earlier, like Slack and Zendesk and Zapier. You want to take data from all of the different sources that you have and have some kind of managed process for getting it into different destinations. DLT can be super useful for that, and that's why I would recommend this package. Of course, for a simple example like this, it might seem like overkill, so I just want to mention that before we move on. Now there's some issues that I want to point out here. If we go back to the user table, notice that we have some nested data, and I think we can see that better if we actually go to the /users endpoint on JSON placeholder. This is the data that we're actually getting back from the API. So you can see IDs, names, and so on. But we have this nested address data, and in turn we have a nested geo object here for latitude and longitude. Now what's going to happen by default is that that nested data is going to be flattened into columns, as we can see here. So the flattening is happening, for example, for the address. We take the field in the address, for example, street, and then we use 2 underscores to create that identifier and then store the data in that column. And if we find the geo column here, you can see that here. We have 2 sets of these underscores and then the data is stored like that. So it's flattening that nested data into one row. That might not be what you want, and you can perform transformations to sort that out if that's the case. And one other thing that doesn't happen by default is that no primary keys are created here. So 𝗏db's REST integration does not create primary keys automatically. And I think some of the reasons for that is that some of the platforms, for example, destination platforms like BigQuery, do not support primary keys. But if you are targeting a destination platform that supports constraints like 𝗏db or Postgres or SQL Server, You can manage these schema constraints manually after the data has been loaded in. Now it's very easy to do this, and I just want to show this example as part of the script. Once we've defined our pipeline, what we can do essentially here after we've run the pipeline is we can get the SQL client that we're actually using to load this into DuckDB. So we can create a context manager here, and we can take the pipeline and we can call a function called SQL client to get back that client. And let's store that client in a variable called connection. And what we can do here is we can add the primary keys manually to the two tables that have been created. So let's take our connection object and we're going to call the execute function to execute some SQL against the database. And we're going to paste a string in here for this SQL statement. So let's do that just now. And it's an alter table statement. So we're going to take the REST API.users table and we're going to add a constraint called users primary key. And that is going to be across the ID field, the ID column in the table. If we go back to the Streamlit application, we can see that the users table here contains this ID column. And if we look at the data, you can see the ID here. We're going to make that the primary key explicitly in the database. And we can do something very similar for posts. That has a user ID, which should be a foreign key. We also have the ID column as well. And it's this ID column we're going to make the primary key here. And notice the schema that's been created is called REST API. And that is what we're referencing here, REST API and then the users table in that schema. Let's copy this to the line below. And we can essentially do the exact same thing for the posts table. And I'm going to call this constraint posts primary key. Now, if we try rerunning this, we're going to get an error because it's going to execute the pipeline again. And it's going to try and load the exact same data from this API. So just to make things simple here, what I'm going to do is delete this DuckDB database. So we can do that on the file system here. And once we've deleted that, let's go back to the terminal here and we can rerun Python REST API pipeline.py. And this is now going to apply these extra operations with the SQL client. And I'm actually getting an error here. It's a catalog error. Table with the name user doesn't exist. And I've made a mistake here. We should be referring to this here, the dataset. So if we go back to the Streamlit application here, the dataset name is this here. We need to refer to that and not the schema name. So that's my mistake there. So let's go back to the application and change this reference here to JSON placeholder API dataset. And if you want to manually specify the dataset, you can pass that argument to the dlt.pipeline function. For example, XYZ, whatever you want to call it. I'm just going to remove that because we don't need that. But you can control what the dataset is going to be called. So let's try this one more time and clear the terminal. And we can run REST API pipeline.py. And let's hope that this is now going to work. Now you can see it's finished without any exceptions. And we now have the DuckDB database again. So let's run that show command. And if you're wondering how I typed that so quickly, check out the video we did on the command R reverse search. That can help you find these kind of long commands on the terminal very quickly. And you can see now this is loaded. And if we show the data here, we still have the ID field, but it should now explicitly be a primary key in that data. Now, as I said, there might be simpler ways to achieve this kind of load from an API. But there's so much more we can do with DLT. We can flexibly switch DuckDB to Snowflake very easily, for example. So we're using DuckDB to test locally. When we're happy, we can then switch that out for a production database or data warehouse. And if you're wondering how to define connection details for a database in the cloud, for example, if we go back to the documentation here, DLT can look for credentials in a secrets.toml file or in a config.toml file. Now, I just want to finish this video by looking at filtering and transforming data. One of the big things DLT can do is not just extract the data from a source and just load it into a destination. It can also perform filtering, it can perform transformations. So let's take a quick look at that. So I'm going to go back to the REST API source documentation. And if we look on the sidebar here, we have a number of different things we can configure. For example, pagination, as we saw, and authentication. We can also have data selection options. But if we go to the bottom here, let's just click this one for processing steps. So for filtering and transforming data. So what we can do in the configuration is add a field called processing steps. And that's going to allow you to apply transformations to the data fetched from the API before it's loaded into the destination. And this can be useful when you need to filter out records or modify data structures, and also for anonymizing sensitive information. Let's go down here and have a look. So for our resources, what we can do is instead of just passing a list of resources to add to the base URL in order to fetch that data, each resource can be represented by a dictionary. So let's take the user data that we have here and perform some transformations. One thing I want to do is just lowercase all emails, so we can do a transformation for that. And let's just do something rather silly and filter out any user whose ID is an even number. We don't like even numbers in this business, so we're going to do that using DLT. Let's go back to VS Code here. And if we go up here, we have the user's endpoint here, the user's resource. Instead of explicitly defining that with a string, we're going to now have a dictionary. And with the dictionary approach, you define the name of the endpoint, which we had before, and that was users. So that's how we get that in the dictionary form. And then we can add a key here called processing steps. Now this is a list in Python of the different processing steps you want to apply to the data coming back from that API. And you can have two kinds of operations. Let's start with a filter operation. And the filter is just going to be a callable in Python. So we're going to take lambda x, and x represents each record from the API. And we can index into that, for example, to get the ID. And if we take the modulus of the ID with 2, that's going to be 0 if it's an even number. So we only want to keep the ones that are not even. So we're going to check and make sure the ID modulo 2 is not equal to 0. So for example, we're going to keep 1, 3, 5 and so on, but we're going to get rid of the even IDs. And we can also have a map step here. So I'm going to create a key here called map. Now what we mentioned before in lowercasing the email, that is an example of a mapping operation where we take the data, transform it in some way, and then return the results. So let's define a function for this called lower email. So the steps here for filtering and mapping, they're just callables in Python. You can define lambda functions or you can define named functions here. Let's go to the top and define our named function. It's going to be very simple. It's going to take each record that comes from the API. And what we're going to do to that record is take the email field and we're going to reset that to a new value by taking the value that came from the API and calling the .lower function in Python to lowercase that. And then we can just return that record. So a very simple transformation on the email field here. And we pass that to the map step of processing steps just by adding the reference to the function as the value. And you can see the callable here for the filter. So we've now taken the user's resource and we've created a dictionary with additional configuration. We don't need to do the same for posts unless you want to actually perform these transformations or perform any kind of filtering. You can just keep the string reference to the resource and mix and match those with dictionaries that contain more complex configuration. So let's now save this. And I've deleted the DuckDB database and we're going to run Python REST API pipeline.py, and hopefully this is going to work if I've not made a mistake. And you can see that's run to completion. So let's now run the show command again and we're going to go back to the Streamlit application. So we're back on the DLT Streamlit application and we can show the data for our users table. Let's see what's in this table, and notice now the IDs are only the odd numbers. We've removed the even numbers because of this processing step. Notably the filter step that we had here to remove those IDs. And if we look at the email addresses, we called lower email as part of the mapping phase. So let's go back to the Streamlit application, which I'm not in the right browser for. And we can now see that all of the email addresses have been lowercased. Now that is all I want to show in this video. There's so much more we can do here. As I said many times, this is a simple example. You might not see the benefit of using DLT just for loading some basic data from an API into DuckDB. But assuming you had a complex organization or lots of data sources, DLT is going to help standardize these pipelines, and it comes with integrations with lots of sources and lots of destinations. And importantly, it's very easy to put this in source control, so you can store your DLT code on GitHub or GitLab. And there's more complex transformations, of course, that we can do here, and normalization of the data. This is just a basic introduction. So with that, if you're interested in any more content on DLT, let me know just below this video. And as I said earlier, I'm adding this to the data engineering playlist. So if you want to know about DBT, Snowflake, DuckDB and more, you can check that playlist out. And finally, if you want to support the channel, check out our Ko-fi page. I'll leave a link to that below the video. And you can also join the channel if you're finding this content useful. And thank you very much to everyone that's joined so far. Now, if you have any further data engineering ideas, please let me know in the comments. I don't have anything more planned at the moment for that particular course, but there's so many tools we could look at. So let me know if you want to see anything in particular. Thanks again for watching, guys, and we'll see you in the next video.